All right, guys, welcome back. And now we are going to do solving inequalities with one variable. And how I'm going to start this is with a thing called graph x is greater than 9. Graph. So normally when we think of a graph, um, we are thinking, of our x and y right here. But when we're just saying x is greater than 9, we don't have to worry about that. I'm just thinking about a number line. So, maybe I'll just put 0 here, maybe 9 somewhere up there. If I'm graphing that, looks like that, right? You guys remember doing these number lines? That would be graphing x is greater than 9. So here we have a greater than sign, and if we were to just take an example like x is greater than -2, then on a number line that would look like, let's say zero's there and we could just put -2 there. Since it's just greater than, we're going to put an open circle, and then we are going to shade to the right because it's greater than, right? We want everything greater than -2. And then this one here is greater than or equal to. So, if I kind of go with a similar example, let's do x is greater than or equal to, that's what that little dash under it means, or equal to, let's say 5. Again, I'm just going to, maybe 0's there, maybe 5's up here. Now the difference is when it's greater than or equal to, we're going to do a closed dot right here. And then we shade in to the right because it's greater than. And then down here we have less than. So if I were to say x is less than 8, again, maybe 0 is here, and we could just say 8 is here. Less than, so we're going to have an open dot, and we're going to go to the left because it's everything less than 8. So that's what the graph of that would look like. And then we have less than or equal to. So if I had x is less than or equal to, let's do -1. So, maybe 0's there, maybe -1's there. For x to be less than or equal to -1, it could be equal, so we're going to do a closed dot. And then less than means to the left. So we're going to have to highlight everything to the left. And that's the graph of that. So now we're going to actually solve these inequalities, and it's the same idea as solving for when it's an equation, except now we just have an inequality there, and then we're going to graph it. So solve the inequality, then graph it. 2y minus 5 is less than 7. Well, I want the y's alone, so I'm going to add 5, and what I do to one side, I have to do to the other. So then I'm going to get 2y is less than 12, right? Because minus 5 and plus 5 cancel out. 7 plus 5 is 12. And then I'm going to divide by 2, both sides by 2. And that's going to leave me with y is less than 12 divided by 2 is 6. And now when I graph that on a number line, I know we've just been working with x's, but you could really put any letter here as a variable, right? So, and I always just like to put 0 in somewhere. Let's say 0 is there, and let's say 6 is up here, and it's less than, so we have an open dot, and then we're going to shade to the left. All right. Now down here, we have 6 is greater than or equal to 2 times, in parentheses, x minus 4. Now, there's 2 ways to do this one, right? I'm going to show you the way I would do it, but it really doesn't matter. It's not really an extra step or anything. One way is maybe like one extra step, but it might be more comfortable. So, one thing we could do is 2 is times this whole entire thing. So if we divide both sides by 2, these 2's are going to cancel out, and we're just going to be left with x minus 4. And then 6 divided by 2 is 3. And so now it's a lot easier to solve. Right now we just add the 4 over to the other side. So then we're going to be left with x on the right side, and 3 plus 4 is 7 on this side. And then I never like leaving my x that way on these inequalities. So I'm going to switch it around. But when I switch it around, right, I have to make sure the inequality still holds true. So x should be less than or equal to 7 when I flip it, right? So if the alligator is eating the 7 here, the alligator has to be eating the 7 when I switch them around too, so that it stays the same. And so that's one way. I'm not going to graph it quite yet. I'll show you the other way. So the other way, we have 6 is greater than or equal to 2 times x minus 4. The other way is we can distribute this 2. So we have 6 greater than or equal to 2 times x is just 2x. And then 2 times minus 4, right? We have to include that minus, is minus 8. And now it's a similar thing, right? We add 8 to each side. And then those are going to cancel out. And then we're going to have 2x on this side. We have the greater than or equal to sign in the middle. 6 plus 8 is 14. And then look at that, when we divide by 2, we're going to get 7. 14 divided by 2 is 7. X on that side. And if we were to flop it or flip it, right, x, and then we'd have to keep the arrow pointing the same way, and we get the same thing either way. Right, so those are the 2 ways to go about something like that. I will leave it up to you for whichever one you feel more comfortable with. But now let's graph it. So now at the end we actually have x is less than or equal to 7. So maybe 0's there, maybe 7's up here. Less than or equal to, so we're going to color in that dot, and then less than is to the left. Right? Now we have a rule. If you multiply or divide by a negative number, you reverse the sign of the inequality. And you might ask, well, why do we do that? And I think that's best illustrated through an example, right? So if we have 3 is less than 5, that's a true statement, right? Let's multiply both sides by negative 2. So if I do 3 times negative 2 and 5 times negative 2, what do we get? 3 times negative 2 is negative 6. And then less than 5 times negative 2 is negative 10. But that's not true, is it? Negative 6 isn't less than negative 10. Because on a number line, if we have 0 here, negative 6 would be here, and negative 10 would be there. So negative 10 is actually less than 6. So that's why when I say we'd have to flip the sign. So right, so since we multiplied or divide by a negative number, when we do that, this sign has to flip the other way. And now that makes sense, right? Now it reads, now that we flipped it, negative 6 is greater than negative 10, which is true if you look at our number line. So now let's get some variables involved. So let's, for the sake of dividing and multiplying by negatives, I'm going to minus 4x here over to this side. And so if I'm putting my x's on the left side, I know I'm going to want everything else on the right side. And so I'm going to subtract the 1 there, and then I have to do that to that side as well. So 3x minus 4x is negative x plus 1 minus 1. We haven't multiplied or divided by anything negative, right? We've just subtracted. So this greater than sign stays. And then 4x and minus 4x cancels out. Negative 2 minus 1 is going to be minus 3. But now to get x alone, we have to divide by -1, right? We divide both sides by -1. Then we get positive x, and now we divided by -1, so we have to flip that sign, right? Instead of greater than now, it's going to be less than, facing the other way, +3. And then graphing it, zero's there, 3 somewhere up there. It's not less than or equal to, so we have an open dot, and to the left is where we need to shade. And then one last example here to get some work with fractions. So we have 3x is greater than or equal to 3/5 times x minus 2 in parentheses. Now, I don't like that fraction there, right? So before, I said maybe you could distribute this into these two, but, with that fraction, it's going to be a little gross. So I want to get rid of it. And how am I going to get rid of that fraction? I'm going to multiply it by 5 on both sides, right? Because if I have 3 divided by 5, and then I multiply by 5, that'll get rid of it. So if I multiply by 5 on this side and on that side, 5 times 3x is going to be 15x greater than or equal to, divide by 5 times 5 is going to cancel out. So now we have 3 times x minus 2. And again, remember I showed you the different ways to do this problem. I'm going to divide by 3 right away because I think that'll reduce our steps. 15 divided by 3 is going to be 5, and then the x is left over. And then we have greater than or equal to x minus 2. And now I'm going to subtract x over on that side. So we'll be left with 5 of something minus 1 of the same something is 4 of that something. 4x is greater than or equal to -2. And then just a little bit. And then we need to divide by 4. Divide by 4. And we're going to get x is greater than or equal to. We didn't divide by negative just because there's a negative there. Doesn't mean we divided by negative. So sign stays the same. And then -2/4 is the same thing as -1/2. Right? Oh no, we got a fraction. What happens now? Nothing different, right? So if we graph that on a number line, zero's there, -1/2 is going to be to the left. And then it's greater than or equal to, so since that equal to, we're going to close that dot, and then greater than is shading to the right. And that is going to wrap up solving and graphing inequalities in one variable.